Welcome to an online video in our courses Empirical Research Methodologies in IT and Digitalization. In this video, we will look at practical problems and how to find one for your project. Your practical problem and your objectives regarding how you will address it are fundamental for your motivation and for the relevance of your results. It's therefore important to have a good understanding of what a good researchable practical problem is. If you have not watched our earlier video on solving practical problems, the research cycle, and our video describing Oates et al.'s research design framework, you should do so before watching this video. You will find links to these videos in the notes section of this video. The research cycle you see in this slide shows how a practical problem is the starting point for research questions, which will in turn allow you to generate new knowledge through your research. The practical problem deals with the real world and how the problem affects the real world and its occupants. On the other hand, a research problem does not directly deal with the real world, but with lack of knowledge. Indirectly, this lack of knowledge can lead to a practical problem not being solved. It is therefore important to understand the nature of the practical problem before starting any research. In this video, we will use the same example that we used in our earlier videos. Imagine that you are working in the IT department of a large insurance company. Your boss asks you to find the best generative AI tool for your department. Our experience from our courses show that students often struggle finding the right practical problem. The wrong practical problem or a practical problem that is not researchable is unmotivating and can lead to bad research. Some of the challenges our students often meet are the following. Students choose a practical problem that is not worth researching. A researchable practical problem means that also others have shown interest in solving it. This means that you should be able to find sources from research and practice that define the problem and discuss its importance and urgency. You also need to make sure that our current knowledge is not enough to solve the problem. As a beginner, you might not be able to prove this lack of knowledge by yourself, but you should be able to quote others who have longer experience. Look for sources and use them in your argument. Another important challenge we often see is that the students have not managed to obtain a good understanding of the practical problem. This might be as basic as not defining the main elements constituting the problem, what we call a conceptual model. A third problem we often see is that students don't approach the problem from their own disciplinary stance. For instance, you might choose a public health related problem that you find interesting, but as an IT student, you need to consider how your disciplinary background and knowledge can contribute to solving that problem. This figure shows Oates et al.'s research design framework we presented in an earlier video. What we have just discussed related to practical problems relates to the three leftmost buttons in the figure. Your first goal when designing a research study is to arrive at good research questions, which will then guide the choice of strategy and data generation and analysis methods. To arrive at good research questions, you need to find and understand a researchable practical problem. You need to show that the practical problem you are interested in is interesting for a larger community of researchers and practitioners. You also need to show you have understood the problem properly by creating a conceptual framework that describes the problem. Here's a simplified process for arriving at a research-worthy practical problem that we use in our courses. The process is taken from a paper by Timothy J. Ellis et al. According to this process, finding a research-worthy problem consists of iterations around 4 steps. Often the starting point and the first step is simply looking around. You might have personal interests, experience, or hunches that put you in the route to solve a problem, or you might have read an article or a paper that triggered your interest. You might have observed a recurring problem in your workplace and become interested in solving that problem. In our generative AI example, the initial seed for the practical problem comes from your boss. Your boss might have heard about generative AI in news, in a conference, from colleagues, etc. She now wants to investigate generative AI as a potential solution to some problems in your department. Your second step should be to look at earlier research to find out what is done to solve similar problems. It is important to remember that you need to have a disciplinary approach that fits with your background and experience. For instance, if your experience is in computing, you will find it challenging to investigate generative AI as a psychotherapy tool, even though you will find numerous research papers on that topic. Avoid getting stuck in reading disciplinary research in areas where you lack sufficient background. One approach is to focus on journals and conferences from your own discipline. See also our video on doing literature reviews. To solve the task of finding a generative AI tool for your IT department, you would most probably need to read about generative AI to understand what it is and what types of generative AI exist. You will most probably also need to read about applications of generative AI in software development, which is what you mostly do in your IT department. It is not very probable that everything you read will say the same thing or point at the same direction. You will therefore need to synthesize what you have read into knowledge that is useful for further defining your practical problem. You need to combine the insights, integrate work from different areas, and arrive at a generalized set of concepts. You need to develop a conceptual model of the practical problem. See also our video on conceptual frameworks. For instance, you might find out that there are several types of generative AI, each one good at addressing a specific type of problem. You might also find out that software development, which is what you will apply generative AI to, consists of many different activities, and generative AI is applied to some of these activities. Once you have gone through the steps and created a draft of a practical problem, it's important to seek feedback from more experienced researchers and practitioners. In our courses, we organize feedback and peer review workshops where your practical problems and research questions will be reviewed by course staff and other students. Make sure to attend these workshops. Looking back at Oates et al.'s framework for research design, we will find corresponding boxes for look, read, and synthesize. Don't forget to take a look at our videos on using research literature and on conceptual frameworks. This video is a part of our courses IT310 and DT8111. To learn more about these courses, go to the links provided in the QR codes in this slide.